6. Today we're learning about fractions. Our WALT, what we're learning to do is to identify equivalent fractions and to reduce fractions to their simplest form. So first of all, let's address that word equivalent. Equivalent, it sounds like the word equals, and that's pretty much what it means. So we're looking at fractions that equal the same, that are the same amount. First of all, what is a fraction? Well, we know the word fraction means part of. Can I have a fraction of your cake? Can I have a fraction of your salary? All right, so a fraction refers to part of something. In a fraction, we have a numerator and a denominator. Our numerator refers to how many parts we have, and the denominator, are how many parts are in the whole. So if I have a chocolate bar split up into 5 parts, and I eat 3 of those parts, I've eaten 3/5. So in other words, a fraction is the number that describes a relationship between a part and a whole. All right, so how many parts is the whole broken up into, and how many of those parts do you have, or how many of those parts are you looking at? So on the board here, we've got 3 different shapes, and they all show equivalent fractions. All right, the same amount of each shape has been shaded in dark blue. This man is going to explain a bit more for us.
When we write fractions to describe pictures like these, it's helpful to think about how many pieces are shaded and how many of those pieces there are in the shape altogether. In the first shape, there is 1 part shaded dark blue out of 2 equal parts altogether, and these are the numbers we use to create the fraction. 1/2, 1 part shaded out of 2 equal parts altogether.
So I really like the point he made here as well. When we are talking about fractions, parts of a whole, they need to be equal. So if it's not equal parts, then it's not fractions. All right, so this shape here represents 1 shaded in blue out of 2 pieces. This fraction here represents 2 parts shaded out of 4 equal parts. So 2 of those parts are shaded blue out of 4 altogether. But looking at these 2 shapes, we can see that that same portion has been shaded in each time. So even though the fractions are different, you've still got an equivalent portion for each whole. And once again, in this shape, we've got 3 out of the 6 pieces that have been shaded in, but it's the same amount each time. So 1/2, 2/4, and 3/6 are equivalent fractions because they show the same portion of the whole being shaded in.
Even though each of these pictures looks a little bit different, they all belong to the same family of fractions, the half family of fractions. The same proportion or the same amount of each of these circles is dark blue, even though there are different numbers of dark blue bits. Families of fractions like this are called equivalent fractions. They are equivalent because they are equal. Even though the numbers used in them are different, each of them represents the same proportion of the shape we're looking at. In this case, a circle.
Thank you, Mr. Mann. All right, moving on. So we can look at these fractions on a fraction wall as well. So what we've got here drawn for us is called a fraction wall, and it shows us how we can divide a whole differently. So on the top row, we've got 1 whole. On the second row, we've got our whole broken up into 2 halves, then 3/3, then 4/4, 5/5, 6/6, and 8/8. And represented like this, it's a lot easier to compare the different fractions.
This is a really useful image to use when we're thinking about fractions. Do you see how each row on this fractioned wall is gradually broken up into more and more pieces? If we follow those fractions from the previous slide down the wall, 1/2, 2/4, 3/6, then we can see very clearly that each of them represents the same distance along the wall, even though different numbers of bricks have been used to make up that distance.
So here what the videos prove to us is that 1/2, 2/4, and 3/3 are the same amount. They're equivalent fractions. So that's been represented to us again. What I'd like you to